Okay, Assalamualaikum. We from class section 2/1 and we will present our mini project Advanced ECF. So we will go through first one. I will talk about chapter 1. So chapter 1, the main thing is a first order circuit. So first order circuit can only contain one energy storage element. That means it will be some other component like capacitor or an inductor. So there are two types of first order circuit. The first one RC circuit and the second one RL circuit. So we go through RC circuit. What is RC circuit? RC circuit in a first order circuit is characterized by a first order differential equation. So in chapter 1 we will learn about how to use Kirchhoff law, Kirchhoff voltage law into the circuit. So we will learn about natural response, how we to find natural response. Then we will learn about the formula from how to find VO, V naught, I naught. So in this chapter we learn to about time constant, tau. So time constant of a circuit is the time required for response to decay by a factor of 1 per exponent or 36.8% of its initial value.
And hi, my name is Muhammad Izzuddin bin Muhammad Zain. I will discuss about the source free RC circuit. So this is the question. If the switch in figure below opens at t equals to 0, find V naught for t greater and equal to 0 and WC naught. So for the first, we calculate for the t less than 0, the switch is closed. So the VC is 3, the resistor will do the voltage division and we will get 8 volt. So V naught is 8 volt. Next, for the t greater than 0, which means the switch is open, we have the RC circuit. It show figure B like this. So we will use the formula equivalent. So we will get 3 ohms at here. Next, for the time constant, we use the formula RC. For the R we get 3 ohm and the C we get 1/6. So the time constant is 0.5 second. Then we will substitute the answer before this to the formula VT. So we will get VT VC 0 exponent negative T over 0.5. So we will get 8 exponent negative 50 volt. So the initial energy stored in the capacitor is 5.33 joule using this formula half CV squared. Thank you.
Assalamualaikum and hi. My name is Muhammad Arif Hashimi bin Muhammad Azman. I'm from class BEEI section 2/1. Okay, so I'm gonna present to you all chapter 2, second order circuit. Okay, for second order circuit, we need to characterize by a second order differential equation. And so they have two type source free for two type source free, one for series RLC and another parallel RLC. The step response is obtained by the sudden application of a DC source. For this chapter, the solution of the equation should have two components. There is the transient response Vt and the steady state response. Okay, so in the step response series RLC, circuit should have three cases. Case number 1 is overdamped, case number 2 is critically damped, case number 3 is underdamped. So in this chapter, for the series, we need to use the KVL to find the answer, and for parallel RLC circuit, we use KCM to determine their cases. So that's all for me. Thank you.
So, my name is Uman bin Borhan. This is the example of steps response of RLC circuit. So, this is the circuit, the example of the circuit. First of all, we have to find the V0. As you see, we use the voltage divider to get the V0, and after that, we can get the V0 50 volt. And I0, we can get 0 ampere. After that, we have to find the value of the capacitor voltage by analyzing the circuit. Okay, we can see the value of the VF is equal to 100 volt. So we have to find the alpha and omega naught. So the formula of alpha is R over 2L, and the formula of omega naught is Z 1 over LC. Okay, we insert the value at the formula. We can get the value of alpha is 8k radian per second, and the omega naught is 10k radian per second. After that, we can know that the circuit is underdamped because alpha is lower than omega naught. After we find the alpha and omega naught, we can find the omega d by the formula Z omega naught square minus alpha square. After that, we can get the value of omega d is 6k radian per second. Next, we input the value to the formula Vt equal to 100 plus B1E negative 8kt cos 6kt plus B2E negative 8kt sin 60V. Okay, first we have to find the B1 and B2. As we see, B1 and B2 is just put the formula, and we can get B1 is equal to negative 50 volt and B2 is 66.67 volt. After that, we insert the value in the formula and we can get this answer. Vt equal to 100 minus 50 exponent negative 8k t cos 60 plus 66.67 exponent negative 8 kt sin 60 volt. So that's all from the step response of RLC series circuit. Thank you very much. Full mark.